And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So if you have not subscribed the channel yet, please subscribe because you don't want to miss any of these tutorials. Today's problem is coin piles, which is marked as a medium level problem, but believe me, the way I'm going to explain it to you, it will become a very easy problem. Let's find out what we will be given into this problem and what we have to do. So we will be given two parameters. First one is an array ARR of integer type and another one is integer k. Okay, what this signifies? So array ARR, each element represents the number of coins in a pile. So here we can see, like in each piles there are two coins. Here we can see in first pile there is one coin, in second pile there is five coins, in third again one, in fourth pile there are two coins, in fifth pile again there are five coins. In this way, like we have the coins and we are also given an integer k. Our task is to remove the minimum number of coins such that the absolute difference between the number of coins in any two remaining piles is at most k. And we can also remove a pile by removing all the coins of that pile. Okay, what does this mean? This means basically we have to return, like we have to remove some coins such that the difference, absolute difference between the number of coins in any pile is at most k. So basically, suppose let's say there are two piles. First one is having one coin and second one is having seven coin. Okay, and my k is, let's say, equal to 4. So we have to remove the coins from these piles such that if any two piles I take, the absolute difference should be at most k. So like here, current the absolute difference is what, 6. So we have to remove two coins such that the absolute difference between any two piles is k. K is basic is 4. Okay, so if I will remove 7 from 7, it will become 5. So it will be like 1 5 and the absolute difference is at most k. Okay, so this is basically what it means, and we can only remove the coins, we cannot add the coins. Your task is to remove the minimum number of coins. Okay, all right. So and we have to minimize our answer, like we have to make minimum removal of coins. Okay, so if we will see this example, let's move to one node where we can like understand it better. So let's say this is our array. Okay, and we have to remove some coins. So let's say if you can see like the current absolute difference is what? Current absolute difference, maximum absolute difference is between this 1 and 5, 4, which is greater than, which is like k is, which is less than, which is greater than k. So current absolute difference is greater than k, which we don't want. We have to do something like if any two piles I take, the maximum difference between them can be k, like it cannot be greater than k. So this is what it is. I think the problem statement is clear now. So look, how many ones are there? There are ones, count is 3. How many 5 are there? 5 count is 2. Okay, all right. So what we have to do basically, suppose and other are only 2, which is basically 2 coins and it has only one pile. Okay, so if, look, if I remove, let's say, like if I, okay, we can only remove the coins. So if I remove, let's say, uh, two piles are there of 5 coins, I remove one from them. So this will have 4 coins, this will have 4 coins, and total coins I removed will be only 2. Now if I will see, like I have removed 2 coins, from one from this, one from this. Now what will be the absolute difference, maximum absolute difference between any of the two piles? So like maximum absolute difference, what I will take, maximum piles and minimum piles, that's only we will get the maximum difference. So here 1 and 4, what is the maximum difference I get? K. 3 I get, which is equal to k, and which is fine. So we can only remove, let's say, 2 coins and we can get our answer. So our answer will be 2. This is what we have to do. I think you have got it. But this is not a way. I've just explained it. We cannot find any algorithm. Like this is not any algorithm to get our answer. Okay. Like this is not the way map use map, and we are not getting anything from here. I'm just trying to explain what the question wants. Now our approach can be like, yeah, look, for each element I will use a brute force type of approach. First of all, what I will do, I will sort the array. Why I will sort? Because now I like we should know ki how much coins we have to remove, and we have to remove like coins mostly from the minimum pile and maximum pile. Minimum coins and maximum coins, like minimum and maximum, if their difference, minimum and maximum, if their difference is less than or equal to k, so like all the piles differences will be less than equal to k. I think you got this. So first of all, what I'm going to do, I'm going to sort it. Let's write it. So it's basically uh, after sort. After sorting, what will array become? 1 1 1 2 5 5, something like this. Okay, something like this after sorting. All right. Now my approach, what I will try. So look, I will do something like, yeah, for each arri, for each arri, I will try to have how many elements, like I will allow how many elements. I will allow only like what I want to say. So for each ARR of I will allow only those elements such that ARRI plus K. Till this point I will allow. Okay. So like 1, this will be allowed. 2, this will be allowed. And 5, this will not be allowed. Why? Because 1 plus 3 4, till 4 we will allow, 5 I will not allow. That's why I have sorted, so that I can know, like 5 I cannot allow, this 5 also we cannot allow. How many elements we have to remove? Like 5. How many, it's how many times it's greater than ARR of I plus K? 1 coin. ARR I plus K is 4, which is 5. 1 coin from here, 1 coin from here, which is equal to 2. So this is our approach. This is our approach which we are going to do. For each ARR of I will allow, like for each ARR of I will say ki yaar ARR I plus K, till this condition is meeting, I will allow. So if any element, let's say ARR of J should be less than equal to ARRI of K. If this condition is true, till that point I will take the J, and after that we have to remove some elements. After that we have to remove some elements. Okay. Now you see we have to remove all the elements from here as well. Let's suppose this pile have, let's do something. Let's take another example now. So another example is basically, let's say 1 coin is here, 2 coin is there, again 2 coin is here. Okay. And like 5 coin is here and 5 coin is here. Okay, something like this. And our K is equal to 2. Our K is equal to, let's say 3. Okay. Now what I will do, like, yeah, look, for ARR of I, for this ARR of I, what I will do, I have to follow this condition, ARR J, such that ARR I plus K is greater than equal to ARR of J. Okay. So for 1, K equal to 3, 4. 1 plus 3, 4. So till 4 I will allow. Okay. So this will be allowed. This will be allowed, and this no, 4. 4 we have to, like, number should be 4 or less than it, but it is 5 which is greater. Okay. So till this point we have to do no deduction, and after that we have to do some deductions. How many deductions? That is basically iterate over all this and subtract ARR of I, like I plus K, ARR of J minus ARR I of plus K. So 1 from here, 1 from here, 2. I have to remove 2 elements. Okay. Now ARR I, again it moved to this point. Okay. To this point, ARR I. Now ARR I is this. So for now, 2 plus 3, 5. Till 5 we will allow. Okay, so this is allowed, this is allowed, and this is allowed. Now we have to don't do any deductions, but we have to remove from this like all the elements which are this. Let's suppose there is one more here. Now we have to remove, let's say 1 5 is there, something like this. Okay, now we have to remove all the previous coins like ARRI, and we are allowing till ARRI plus K, and we have to remove all the elements from the starting. Because now if I will include 1, I cannot include 5 because the absolute difference, if I will include 1, I cannot include 5 because the absolute difference will be 4, which is greater than 3. So we have to remove the previous piles. All right, so now we are coming to our intuition, like we are coming to our approach. What approach? Let's say again I will do something like 1 comma 1 comma 2 comma 2 5 5 and 5. Okay, so for this test case we have to remove only 2 coins. What 2 coins? These 2 coins. Okay, now how are we going to do it? Like first loop, there will be one loop which will run for each ARR because we have to do something for like we have to do a process for each ARR of I. Okay, one thing is there. Now after that we have to again, let's say, remove some piles from the starting, and we have to remove some coins. We have to remove some coins from the piles in the afterwards. Okay, so again I have to iterate this whole pile. So the total time complexity in this case will be n square, because look, we have to, if I want to include 1 1, so we have to remove some coins from these piles 5 5 5. But if I want to remove these piles 1 1, so we can take all of these. So like we have two choices, and we have to minimize the number of coins removed. Okay, so here if we will see, the ARR size can be 10 raised to the power 5, and if I will take n square time complexity, we have to get time limit exceed. We will get time limit exceed. Okay, so we have to think of a better approach. What better approach we can do? I will have a pre-sum. I will have an array, basically prefix sum. Okay, guys, I'm trying my best to explain it, and I think you guys have got what I want to say. Prefix sum. So till this point, prefix sum will be 1. Till this point, prefix sum will be 2. Till this point, prefix sum will be 4, 6, 11, 16, and 21. Like till this point, at any point, let's say till this point, the sum of array elements is equal to 6. Okay, now you see with this, if let's suppose I am starting from ARR of I am starting from here, so we have to remove all the coins of previous piles. Why? I have already told you why. So how can I remove? Just get the prefix sum. Just get the prefix sum 2. Okay, I've got the prefix sum 2, and we will remove 2 coins. It means we will remove 2 coins. Okay, now one more thing which we can benefit from here. Let's suppose my ARRI is this. Okay, so we can only include till this point. Now we have to remove few coins from here to allow these, because like total coins from here to here should be at least 1, and k is what, 3 4 4. So we have to remove 1 coin from these piles. How will I know? How will I know how many coins I have to remove? So there is a very good way to that as well. What I'm going to do, 21, total sum is 21. Till this point sum is 6. Okay, so total coins in this, between this, is what, 15. Okay, total coins is 15. How many piles are there? 3 piles. And how many, what sum is allowed? So 1 minus 5 minus 1, 4. So 4 sum is allowed. 3 into 4, which is equal to 12. I will remove 12 from here, and I will get 3 coins. So for this ARR of I, we have to remove 3 coins. That's it, guys. That is what we have to do. And one more thing is there, like you see, we can use prefix sum to get all these in big of one time complexity, constant time complexity. One more point is there, like for this ARR of I, how will I know till which index we are allowed? One condition, like one approach, is basically iterate over this whole array again, which will result in n square time complexity. So what we can use, like suppose if I have to find the index, I have to find the index such that there, like suppose till like for one, how many items, like what is allowed for one, 1 plus k equal to 3 4. So till fourth we have to, we can still till 4 element I can allow, like 4 value. Now if, how can I get like what index, what is the first index with element greater than 4? What is the first index with element greater than 4? How can I get? I can get it through binary search, because this array is already sorted. We have to get the index of that element whose, with whose value is greater than ARRI plus K. So we can get that from binary search. So in this way, we can get our answer. Guys, I think you guys have got it. And when I'm going to write the code of it, all this I have explained to you will make you all the sense. So let's move on to the code section. But before that, if you have not subscribed the channel yet, please do subscribe, because I'm trying my best to explain it to you. And let's see the code. But before that, you can see this brain icon here. So this is the Chrome extension I have built for you. Like suppose you are watching this video tutorial, so you have to revise this problem again. How can you keep track of the problems which you have to revise? I have made the Chrome extension for that only. Just click on plus. Here you can see all the entries are already filled. Just click add for review. And you can see coin piles you have to revise again on 23 June, like which is 6 days after. So if you are wondering how you get 6 days, so there is a field here which you can revise after days. You can change it to 3 4, and then you will add it. It will, like you have to revise it after these days. So like suppose Coco eating bananas, I added few days earlier, so now I have to solve it today. Once I will solve, I will mark it as solved. If you want to resolve it, click on resolve again. Okay, let's say mark as solved, and it's solved. Okay, all right. So if there is also a feedback form here, if you want to do any, give any feedback, give it here. Subscribe the channel as well. Let's move on to the code section. So the first thing which I have to do is arrays dot sort AR. Okay, all right. After that, I will try to store a variable in n is equal to ARR dot length, so that I don't have to write it again. I will create a prefix sum array. Prefix is equal to new int, and its length will be basically n plus 1. Okay, I'm going to iterate over this whole array. I equal to 0, I is less than n, I plus plus, and prefix. Okay, prefix of I plus 1 is equal to prefix of I plus ARR of I. Okay, so like basically we will start filling it from one index. We will start filling it from one index, because like prefix sum, we will not include that index. Like for one index I have not included one, like one index sum. Okay, for two index, for two index our prefix sum will be 0 and 1 index sum, in that way. Okay, for two index. All right, so after that what I'm going to do, I will have one answer, let's say, which is currently maximum integer dot max value, and we have to minimize it. Okay, now guys, please focus. I will again iterate over this array. Int I is equal to 0, I is less than n, I plus plus. Okay, what we have to do, we have to remove some coins from the left, and we have to remove some coins from the right. How many coins we have to remove from the left? Let's say int rem left. How many coins? It's basically equal to prefix of I. Okay, prefix of I. And after that, how many coins we have to remove from the right? For that I have to get this index. For that I have to get this index, like till this point, till what point we are allowed. Okay, so let's say I have a variable upper, which will give me okay, upper bound. Let's name it upper bound, and I will pass few things here. First one is an array ARR, and second one is what is upper bound, like what till what elements we are allowing in this array, till what elements. So what element? ARR of I plus k. Till this point only the elements will be allowed, and after that, like if the elements are greater than this ARR I plus k, we have to remove some coins from them. From that piles we have to remove some coins. So how many coins we have to remove from the right? Let's say rem right. How many coins? Guys, I have already told you. First one is basically, if you remember, prefix of n minus prefix of upper bound. Okay. So first of all, I will write prefix of n minus prefix of what? Upper. Okay. And after that, I'm going to, like, till this point I have got 15. So we will get say ki how many coins are allowed in this, like 555. So how many coins are allowed? Like total 3 indexes are there, and each will have only 4, like ARR I plus k. So how many indexes I will find out first, which is n minus upper, these many indexes, and into in all these indexes can have maximum what? All these indexes can have maximum ARR I plus k. So this is what we have to remove from the right, and after that what I'm going to do, I'm going to update my answer to what? Answer is equal to math.min of current answer, comma, rem left plus rem right. This. I think you guys have got it, and once I will come out here, I will simply return my answer. So this is what we have to do. We just need to implement this upper bound function, which is extremely easy, a binary search. Let's do that as well. Static, I will remove int, return int. Function name is upper bound. It will get two things, int array ARR, and second one is, let's say, any value v. Okay. Array is already sorted. I will have some things like low is equal to 0, high is equal to ARR dot length minus 1, and let's say answer is currently minus 1. Okay. While low is less than equal to, low is less than equal to high, I'm going to calculate the mid. Mid will be equal to uh, low plus high divided by 2. Very, very simple. Okay. And after that, I'm going to check ki yaar, if, look, if ARR of mid is less than equal to V, it means we have to search in the right. How can I search in the right? I will do something like low is equal to mid plus 1. Okay. Otherwise, we are going to search in the, like, if this is false, it means our V, our upper limit, is in the left side. How to go in the left side? I will do high is equal to mid minus 1. That's it. And here I will also store answer is equal to mid plus 1, because possible answer is only mid plus 1. Till this point we are good. So mid plus 1 can be our next, like, possible answer. And once I will come here, I will simply return answer. That's it. Let's try to compile this, and meanwhile please subscribe the channel and like the video, because it will really motivate me a lot. Let's try to submit it, and make sure to check out this Chrome extension. This code you will get on my GitHub. Make sure to follow me on GitHub, and if there is any new code you coded, make sure to make a merge request on my GitHub repo, and I will merge it. In this way you will also learn how to use GitHub, and guys, it's getting accepted. So that was it for today. I hope you have definitely liked it, and you will subscribe the channel, like the video, comment down how was the explanation. I'm going to see you again tomorrow. Till then, keep on coding, and bye.